Today we're just going to kind of focus on mostly vocabulary. Okay, but this is important in math. In math, when we talk about math, it's English and math don't mix well. And so when but we communicate usually in terms of English. And so when we want to use English words to describe what we're doing in math, we need to use the right terminology, or it's unclear what we're talking about. So let's start here. What's a variable? What do you remember about variables? Okay, kind of. How do we usually write a variable? Okay, yeah, letter or a symbol. And what's the one we usually use? X. Doesn't have to be, but usually be an X. Variables are things that can vary, right? It represents not just a single value. A variable represents, a whole bunch of values, a number that could vary or change depending on the situation, right? How's that different from a constant? What's a constant in math? Say it again.
Something that's always there.
Something that's always there and doesn't change? Stays the same, right? A constant is something that stays constant, just like it sounds. So it's a number that's added or subtracted in an expression. It's something that does not vary. And this when we talk about a constant in the context of we're going to talk about expressions, we're talking about the thing that's being added or subtracted usually. What's an example of a constant? Yeah, the number 1. What's another one? Number 2. Anything that's just a plain old number is a constant, right? Pi would be an example of a constant. A constant could be a symbol, by the way, but if it's a constant and it's a symbol, it just means something that doesn't change. Okay, how about a coefficient? What's a coefficient in math? Remember? What's a coefficient? Think about where it comes in a math expression. Where do we write? They always sit kind of in a specific place. In front of what? Be brave. Coefficient. Okay. Coefficient, draw on a blank. Coefficient it's a number that sits in front of a variable that's multiplied by a variable. Is that ringing a bell? Okay. When we talk about something in math as being numerical, what does that mean? Say it again. Yeah, so very close. It involves numbers. Numerical relates to numbers, so it only involves numbers. Math, the kind of math you did for a long time in grade school was all numerical. You didn't ever use anything other than numbers, right? Not anymore. Now we do math that's algebraic. What does algebraic mean in math? Okay, numbers and variables. Yeah. So algebraic math involves variables and numbers both. In math, when we talk about operations, what do we mean? What's an example of an operation in math? Okay, so addition, right? Addition's an operation. We can add things. What's another one? Subtraction. What's another one? Multiplication, division. Okay, anything else? So PEMDAS is order of operations. That tells us the order in which we do operations, and we'll talk about that soon. There's a couple other ones that you guys have done that you're not mentioning. We can take roots. What else could we do? Exponents. Yeah, we can do exponentiation. So there are other operations, but for now, that's really basically all you've ever done. Maybe there were some other ones in there too at some point, but that's about it for the most part. Those are the operations. Okay, what about an expression versus an equation? So these are different things, and we need to be able to understand this difference, because this is kind of important too. Let's start with equation. Say it again. Okay, so equations, hold that thought, that's important. So equations have, usually, sometimes they don't, but usually they have solutions. Okay, we'll get back to that. Equations are very easy to spot. How do you know immediately if you're looking at something in math that it's an equation? It's got an equal sign, right? Equations have equal signs. So an equation might look like there's this equal sign and there's some stuff on the left side of the equation and some stuff on the right side. The things on the left and the right side are less than equations, right? They're just parts of equations. Those are what we call expressions. Expressions in math are just smaller things than equations. They're just combinations of numbers and variables that are connected by operations. That's it. And an equation is just an equal sign that separates two expressions. Okay? So here are examples of expressions in math, right? They involve variables and numbers and operations, division, exponentiation, roots, etc. Okay, so let's practice this a little bit. Let's take this expression, and I want you guys to answer some questions for me about this. So z is the, well, you tell me, what is z? It's the variable, isn't it? Yep. Z is the variable. Okay, now I want you to vote with your fingers here. 1 for A, 2 for B, 3 for C. What is the negative 11? But don't say it out loud. I want you guys just to vote with your fingers here. 1 for constant, 2 for coefficient, 3 for variable. What do you think? Need to get a little feedback here. How are we doing? Well, I've seen lots of 2s. I agree. It's the coefficient. It's the constant that's being multiplied by the variable. Sits in front of the variable. What's 13 then? 1 for constant, 2 for variable, 3 for coefficient. 1. It's the constant. It doesn't change. It's a number, and it's what's being added or subtracted in the expression. Okay. Give me 1 to 5 on this so far. 5 meaning I got this. 1 meaning I don't remember any of this stuff. Where are we on the spectrum? You can be sneaky about it, but I need to get a little feedback from people so I know how we're doing. Okay. Thank you. So some other terminology. Now, a lot of times in math, we get lazy about terminology. Like we might say something like, for this problem right here, find the value of A times B when A equals 7/8 and B equals 3/11. A lot of times people would say, oh, I can't solve that. I'm having trouble solving that. Solving is the wrong word there. Because what does solving always involve? If I'm solving something, it's a certain kind of a problem in math. An equation, right? You only solve equations. You don't solve anything else. You find solutions of equations. That process is called solving. This is not solving. What is this? This is something totally different. This is called evaluating. That's different than solving. In math, value means number. And so when we talk about evaluating an expression, it means we're plugging in numbers and figuring out what numbers we get back, right? We're plugging in input values and figuring out what the output value is. So how would I do this? It says find the value of, what is that? AB. So what does that mean if I put two things next to each other in math? Multiplied. Okay, good. So find the value of AB or A times B when A equals 7/8 and B equals 3/11. How would I do this problem? How would I evaluate this? Yeah, I'm just going to plug in these input values for A and B and figure out what I get when I multiply them. How do I multiply fractions, by the way? Do I do diagonal stuff at all? No. You're thinking of solving a proportion, I think. Multiplying is super easy. What do? Straight across, right? Multiply straight across on the top and the bottom. So I would just multiply 7/8 times 3/11. What do I get on the top? 21. What do I get on the bottom? 88. Yeah, and I can't reduce that. Okay, so that's my answer. Okay, let's just look at one of these examples, and then we'll move on to one last topic for today. You guys remember what time we get out of here? 11:10, you said? Okay, so yeah, when we get to 11, remember to make me stop. So the 747-400 aircraft costs $8,443 per hour to operate. Write an algebraic expression representing the cost of flying the 747 for T hours. What in the world does that mean, by the way, for T hours? Yeah, what's T here? It's a variable. And what does it represent? The amount of hours we're flying. Why is it probably a good idea to have T be a variable instead of a constant there? Yeah, because the amount of time I'm flying this, we might want to change that, and figure out what the cost is for multiple different scenarios, not just one, right? So we want that to be a variable. So what would that expression look like?
A1 to 43.
8,443 t times t. I like it. I agree with you. Okay, so that's the expression. Okay? What happens if we write it that way? Have you seen that? You've seen that stuff before. What kind of notation is that? What kind of notation is that? Starts with an F. Function notation, exactly. That's function notation. We'll talk about functions later. But let's just mention it now because it's so important in math. We're going to use these all year long, very important. Does that mean c times t? No, how do we say that in math? We wouldn't say c times t. How did Mr. Hagwood or Mr. Morioka talk about that a couple of years ago? They had stuff like that. What word did they use to connect the c and the t? What? Of, yeah. That's c of t. That's how we'd say that, c of t. And what's that mean? Well, when you see something like that with function notation, it's telling you that the variable that's in the parentheses is the input variable. Those are the values that we're going to plug into the function. And the variable that's out in front is the output variable. So in this case, what's our input variable? What values are we inputting into our expression? T, values of time. How long were we flying the plane? What are we calculating? Because what we're calculating is the output variable. What's the output variable? Oh, okay, gotcha. We're out of here at 11, you said 11:10 or 11:05. Okay, yeah, I probably need to quit here. Last thing we'll talk about. What's the output variable? C. It's C. What does that stand for? Doesn't that make sense? Aren't we trying to determine cost? The thing that we're trying to determine is the output. To determine it, we have to plug in specifically what are the times we're talking about. So the input is the time, the output is what we're calculating from that time.